Now, statistical inference problems are further classified into two parts. One are called parametric statistical inference problem, other are called non-parametric statistical inference problem. So, statistical inference problems are again classified into two parts, parametric statistical inference and the second kind of problems are called non-parametric. So, let us see what you do in parametric statistical inference problem. Now, in this case, the P star, which is basically the class of distribution functions, this is characterized by certain parameter or certain set of parameters. So, what you know is your unknown distribution function f belongs to a family, and that family is characterized by a parameter theta. So, here the form of f theta is known, the only thing unknown to us is theta. Form of f theta is known. So, when I say form, it means functional form, and theta is unknown. So, in this case, what you are interested in is your mu of f can be written as mu of theta, because the functional form of f theta is known. The only thing which is unknown is theta. So, as an example, you could be interested in a situation where you have a sample x1, x2, xn, which are IID from normal theta 1. So, in this case, what is your f theta x? Is minus infinity to x 1 by root 2 pi e to power minus half t minus theta whole square dt. And my P star is nothing but f theta, such that theta belongs to theta. Of course, here theta could be anything real line. So, what I know in this case is, if this is the situation, what I am assuming is the height of Indian males is normally distributed with mean theta. So, the only thing unknown to us is theta. So, I know that height is bell shaped, very much behaves like a normal distribution whose mean is theta. So, the distribution of x is normal theta 1 for some theta belonging to R, which is unknown to us. And my goal may be to test validity of certain statement about f, which is equivalent to saying that I am interested in testing validity of certain statement about theta. So, for example, I may be interested in estimating the mean of theta. So, mu of theta could be theta. This could be estimation. So, in estimation, you are interested in estimating theta, and you have studied various procedures in your first course about estimating theta. So, for example, method of movement estimators you know is x bar, which is 1 upon n summation I is equal to 1 to n xi, which is nothing but sample mean. So, in the normal case, it says method of movement estimator says that whatever sample you have taken, take the sample mean out of those observations x1, x2, xn, and take that as estimate of this. This is also the MLE. So MLE is also X bar. You also saw that X bar is the uniformly minimum variance unbiased estimator. So that is the estimation part of it. Let us look at the testing part. Now in testing part, what you know is you are interested in testing a validity of a statement against an alternative statement. So for example, you may be interested in testing H naught theta less than or equal to 0 against the alternative that theta greater than 0. So this is all you did in your first course. And then using Neyman-Pearson lemma, you knew how to test this procedure in an optimal manner. So this is the situation of a parametric statistical inference problems. So here, the unknown distribution function f belongs to a parametric family. So that means f is of the form f theta, where functional form of f theta is known, but this theta may be unknown. So as example I gave it over here, you may have a sample from normal theta 1. What is non-parametric? Non-parametric statistical inference problems. Here, nothing is known about unknown distribution function f, except possibly that f is continuous or discrete. Except possibly that f is discrete or continuous. So this is a broad description between the parametric statistical problems and non-parametric statistical inference problems. So let us try to see what are the basic components of statistical inference problems. So one is the P or theta. So I'm trying to look at the elements of statistical inference problem. So first is, it should be known to us what is the class of distributions I am studying. What is the parametric space I have in the case of a statistical inference problems. So this theta, which belongs to capital theta, so I know my distribution belongs to some family. And that family is characterized by a parameter theta, which takes value in capital theta. This is called parametric space. Now, name parametric comes from the parametric statistical inference problems. In non-parametric inference problems, I'll have a class of family of distribution, because there the distribution function is not characterized by any parameter. Then I have a data, x1, x2, xn. What I know is x1, x2, xn has a distribution function f, or f belonging to P, or f theta, theta belonging to capital theta. So this is a case in parametric statistical inference problem. This is the situation in non-parametric statistical inference problem. Then you have mu of f or mu of theta. This is a parameter of interest. So what do you do in statistical inference problem? As I said in the beginning, based on this x1, x2, xn, you try to make certain inferences about mu of f or mu of theta. Or in other words, based on x1, x2, xn, you make certain decisions about mu of f or mu of theta. Or equality, what it says is after the observations have been taken, based on x1, x2, xn, you take certain actions about decision concerning mu of f or mu of theta. So then I have a concept of action space. Which is nothing but set of all possible actions. So to see an example of action space, let us consider x1, x2, xn is a random sample from a population with PDF or with distribution function, let us say f theta x, which is 1 minus e to power minus x by theta, 0 if x less than 0, where this theta is unknown to us. And I am interested in estimating probability that x is greater than 1. Probability x greater than 1, you know, is nothing but e to power minus 1 by theta. So what is the action space? Here action space is anything, because probability is between 0 to 1, so you would have an estimate of mu theta, which is a probability, would be between 0 to 1. So after you have taken a sample, you will tell one estimate, or you will give one estimate whose value lies between 0 to 1. And that is why the action space here is 0, 1. So this is a parametric space, parametric inference problem. So this is an estimation problem, parametric estimation. Another problem could be to test h naught that theta is equal to 1. That means the mean of this exponential distribution is 1 against h1 that theta is not equal to 1. So what I have to do in this case? I have to test the validity of this statement against this statement. So what are the actions available to me? Either I accept this statement or I accept this statement. So my action space in this case has just two elements, 0 and 1. I can call that my action is 0, which is equivalent to accepting h naught. So 0 corresponds to accepting h naught. This is just 0 is a symbol. 0 is a symbol which symbolizes that I am accepting h naught. And 1 is about accepting h1. So in this case, my action space has just two elements, 0 and 1. And this is a typical parametric hypothesis testing problem. So what I'll so this was basically a brief description of statistical inference problems. So what I'll do in the next module is we'll talk about parametric estimation problems in more detail. And that we'll do in the next module.